Hello everyone, myself Rahul. So today we are going to solve a problem related to linked list. So problem name is remove duplicates from sorted list. So let's go through the problem. This is a very simple problem. So here we are given a head of a sorted linked list. Delete all duplicates such that each element appears only once. Return the head, return the linked list sorted as well. Right. So here we are given a sorted linked list and we have to remove duplicates from the linked list, right? So the linked list is suppose 112 and we have to remove one from this linked list because one is occurring two number of times, so we have to just keep only one, right? So 12 is the final linked list that we can return. Similarly, the other example 1 1 2 3 3, so we can see this one is occurring two number of times, so we just keep only one out of that. So 1 2 is only occurring one number of times, so we keep 2 as it is, and 3 is occurring two number of times, so we remove one of those threes. So finally we return 1 2 3, right? So this is what we have to return, and these are the constraints that are already given to us, and the list is guaranteed to be sorted in ascending order, right? So there won't be any problem regarding that. So what are the approaches that we can take to solve this problem? So let me write one example so that we can discuss on the brute force method and an optimized one. So let's take an example to be 1 2 2 3. Let's create another 3, suppose 4 over here. Yeah, so suppose this is the linked list and we want to convert this linked list in such a way that one occurs only once. Out of these two occurs only once, and out of these three threes, three occurs only once, and 1 2 3 4, right? So each element has to occur only once. That's what I have to return. So how I'm going to solve this? So this is the input given linked list, right? So the brute force method to this approach can be solution can be we create a new linked list altogether, in which what I'm going to do is I'm going to insert an element if that element was not already present in the linked list. So suppose I start with the head of the input linked list, and my new linked list NLL will have this one, right? So I move to the next element of the input linked list. I compare this two with this one, but they are not equal, which means this 2 can be inserted, so I inserted 2 over here. Then I move one point next to in the input linked list. I compare this 2 with this one. These are already equal, so I won't be inserting this 2 into my new linked list. Instead of that, I will be jumping to the next element. So I compare this 3 with the last element of this new linked list. So 3 is not equal to 2, which means I can insert this 3 into my new linked list. Then I will jump one step more. 3 is equal to 3, which means that need not be inserted again. Then I will go one step ahead. These 3 and these 3 are compared. These are already equal, so I can't insert it. Now I will be comparing 4 and 3. So they are not equal, so I can create new node with 4 as value. Right, so this linked list I can return directly with head pointed over here. Right, so here we are creating a new linked list, and we are iterating over the input linked list once, right? So time complexity wise it is O of n, where n is the number of nodes in the input linked list, right? So we are iterating over the linked list, and we are basically covering one element only once, so that's why the time complexity is O of n. And the space complexity would also be O of n, because in the worst case all the nodes in the linked list can be unique. So suppose this is the linked list 1 2 3 4 5, right? So what is the new linked list that I have to form? New linked list would be exactly same as the input linked list. So the maximum size of this new linked list can be the maximum size of input linked list, which is n, right? So this is the brute force method, and time complexity and space complexity as mentioned over here. So can we somehow improve on the space complexity part, because here we are kind of unnecessarily creating the new linked list, right? So can we use the existing linked list to rearrange the elements in such a way that we are able to remove the duplicates? So let's consider the same example with the better approach. So the optimized approach can be, So same linked list can be taken. Let's take it this. So if you have used the two pointer approach in arrays, so same approach can be used in the linked list as well. So what happens in two pointer is we create two variables. So in this case, let's call them temp1, which is starting from the head of the linked list, and temp2, which is starting from the next element. So at every step, what I am going to do is I am going to compare whatever the value is present in temp1 and temp2, right? So value, if temp2 value, yeah. So if temp2 value is not equal to temp1 value, right? So it means these are totally different elements because their values are not equal. So in that case, I need to consider this temp2 node as well, right? So in that case, I can mark my next pointer of temp to be temp2. So the next pointer of this one will be pointing to this 2, and I can simultaneously update my temp1 to temp2. So my temp1, instead of pointing to 1, this one, it will move from this to here, right? So let's call it T1 and T2 for the sake of convenience. So T1 will move over here and T2 will go one step ahead, right? And similarly, T2 is equal to T2 next. T2 is nothing but temp2. I'm just writing it as a short form. Now I'm again going to compare this value and this value. These are already equal. So I don't need to update my temp1. Instead, I can just increment my temp2, which is T2. Right, so now I compare this 2 and this 3. So these are not equal. Then what I need to do is I just need to uh, increment or update the next pointer of this 2 to this 3. So the next pointer of temp1 can point to temp2, right? So that's what is being done in this step, and I can update my temp1 to here and my temp2 over here, right? So similarly, this T1 and T2 are compared. These are already same. I can again increment T2. Similarly, this 3 and this 3 are same. So this if condition won't be valid, and T2 moves over here. And this T1 and T4 are compared. So I can update my next pointer of this T1 variable to this. So updating the next pointer ensures that these elements, these duplicate elements between T1 and T2 are skipped. That's why we are updating the next pointer. Right, so I hope the approach is clear. Let me quickly code this. So the code for this is very small. I guess around 4 to 5 lines code would be there. So I will create temp1 equal to head. Similarly, I can create temp2 is also equal to head next. Right, and I can write one while loop which can continue till the temp2 is not equal to none. And here I need to compare the value of temp1 and temp2. If temp1 value is not equal to temp2 value, which means these are completely different values, then I need to update my next pointer of temp1 to temp2, and temp1 can be updated as temp2. And in either cases, like if even if this if condition is not valid, I just need to update my temp2 as well. So temp2 would be temp2's next, right? Right, and finally I can return after this while loop is completed. I can return my head pointer. And one more thing I have to do is once this while loop is completed, I just need to update my temp1 next pointer to be null. Why I have done this condition, I will tell you. So suppose this 3 and this 4, yeah, so suppose in the cases, so let me take an example to understand this. So 1, 2, 3, 3 and 3, right? So initially T1 is over here, T2 over here. T1 in value and T2 our value is not same. So one next pointer is pointing to 2, which was already, but we are still updating that. So T1 moves over here, T2 moves over here. We are comparing values at T1 and T2. These are not same. Again, 2 next pointer will be pointing to over here. So we update T1 here and T2 moves over here. T1 and T2 values are same. So we don't go inside this if condition. We compare T2 moves over here. So we again compare this T1 and this T2. These are already same. So we don't go inside this if condition. Now T2 moves over here, which is null, right? So we would be reaching the termination condition of the while loop. But the thing is, like still, if we look at the linked list 1, 2, 3, so temp1 is pointing over here T1, and the next pointers of this 3, 3 and all are also attached, right? So we need to detach these nodes from here. So that's why T1 is over here. So I just need to make the next pointer of this to be null. That's what I am doing in this basic step, right? So I will run this problem. Yeah, it looks fine. I will submit it. There looks to be runtime error. The last executed input. Okay, if the head is empty, then in that case, the head is itself null. Then we can directly return that. Right. Let's see. Yeah, runtime memory usage perfectly fine, and it ran successfully. So I guess the solution is clear, and it was a very basic problem related to linked list. There are a couple of similar questions mentioned over here. Remove duplicates from sorted list 2 and remove duplicates from unsorted linked list. Right. So in this question, I guess if we go through this, what's there in this? Let me open this. So here we just need to remove all the elements. We don't have to even keep a single copy of that particular node. So in this example, 1, 2, 3, 3, 4, 4, 5. Right. So 1 is occurring only one number of times, so we keep that node. 2 is occurring only one number of times, so we keep that. 3 is occurring two number of times, so we completely remove 3. Similarly, 4 is occurring two number of times, that is more than 1, so we completely remove 4. Right, so this problem can be solved by minor modification to the earlier solution. If we go back to the previous problem, there is another problem over here. Remove duplicates from unsorted linked list, which is this one. So in this, let it open. Okay, this is locked one. So basically, if you open this question in the Geeks for Geeks, basically here the linked list is unsorted instead of the sorted one, and we need to remove the duplicates. So how can we solve that? We can basically maintain a hash map of the visited nodes and remove the duplicates by iterating over the linked list only once. Right. So it's a basic addition of hash map into the existing solution. That's it. I guess the solution is clear, and if you have any queries regarding this question or any of the similar questions, then you can basically comment. And I hope I will see you next time. Until next time, take care. Thank you.